Okay, hey everyone. Can you actually see and hear me? I was getting some weird issues happening with my OBS. I use Streamlabs OBS, and it literally started sending me my like report stuff of like, hey, here's your stream report from July 15th. You streamed for 3 minutes and had no one watching. I was like, wait a minute, I'm still live. That doesn't sound right. But hopefully you can see me. Kenzie, I assume that the party time means you can see and hear me, so we can go ahead and get started. Cool. So today we're going to work some more on some Suave Keys stuff. Basically, where we left off was we implemented some account management, user password management stuff as a means to handle authentication, and we're going to do a little bit more of that before we get into like what I think will be the super interesting stuff. So just to sort of recap where we're at, I was trying to pull up my draw.io diagrams that I literally built on stream, and when I go to open recent, there's literally nothing. Oh, cool! It's literally just crashing now anyway. Sick. All right, hold on. We're just gonna go ahead and just try this whole draw.io thing over again. Okay. So I wanted to pull this up, that way I can actually have it up as a talking point. But when I go to open recent, literally the stuff that we drew like a week ago is just gone. And when I go to open, I can't find the files. I literally, so what I did is I went to my videos, right? I went to my stream where I saved. I was like, I'm pretty sure I saved these before I just quit. Pretty sure I saved these before I just. Now we got an infinite loop. Now we got this one. All right, so I scrubbed through it. When we got to the drawing part, somewhere in here. Cool. So now that we have that user, or the other way around, and like, I was like, I know I saved it because all of a sudden it had the title up there, and I had to like scrub to like the perfect time, and it saved the documents, but for whatever reason, it's not showing up. But here it is. So I think I'm gonna try something here. Just rename these to XML because I don't think these actually have file extensions. So I don't know who I might know on the draw.io team, but like that's pretty frustrating. So yeah, now they show up. All right, let's see if he's actually open. All right, cool. All right, I'm gonna keep these up because I've been trying to use them as talking points, and instead I like switched to hand. Now we can actually show it on the screen. I'm not sure we need to go back and play that you start the inside. Yeah, we're just gonna have an infinite loop of like exponential Alex growth. All right, here is our auth diagram. Did the other one close? Can I not have more open at the same time? No audio on full screen video. Oh, word. All right, it's probably the mic is turned off. Thanks for the heads up. I'll try to fix that later. Hydrate. Sure, Kenzie. So I'm actually drinking coffee right now because I didn't get any sleep last night with our new foster puppy, who hopefully will be making an appearance at some point. So I'm just running on coffee at 6 p.m. Eastern over here, so it's pretty brutal. Anyway, so here's our auth diagram, right? And basically we have like the same user who needs to be able to authenticate from like at least 3 different types of applications. Never mind that like within each one of these like categories of like clients and web and the conversation or voice side of things, like within each of these there's n number of actual end client apps. Like you could have the same account signed in on your Windows app and your Mac app and like Android and iOS, and within the voice channels, like you want to set it up on Alexa and Google and Bixby, and like our custom voice app will end up building, and you got to be able to sign into web to actually like do all this stuff. So basically where we left off was that we built our own user account. We were trying to work with identity in .NET, and it was just giving us so much grief that I decided to just back out and roll it myself, because like the way I wanted to have it set up in order to support all these channels was either going to have to be like full heads first dive into identity and like let it run a lot of it, or really just Frankenstein a mix of identity and custom stuff, or do it custom. And I didn't want to just go full identity. I wanted to Frankenstein it at first, and we just ran into some trouble. But that's besides the point. So what we have now is some home rolled stuff. So we have a user entity. It got an ID, first name, last name, email, and password hash. Really, we don't want to know too much about our users for their privacy. We only really need their email and password, which I might even just get rid of these fields in general. I don't really care to know much about them. I just want them to be able to talk to their keyboard. And we have an auth client and a refresh token table. So these are literally our only 3 tables so far for our entities. And then we're running everything through entity framework. We've got the repository pattern set up. Everything's running through a clean/onion-ish architecture where we've separated our business logic and data logic and our controller logic. And it's looking pretty good. So the idea is that we're able to sign in with different grant types. Right now we're supporting the password grant type, which is technically pretty sus. And we've also got our refresh token grant type. So when a user signs in the first time by supplying their username and password, we hand back an access token and a refresh token. And then they can re-authenticate or transfer a refresh token for a new access token, since those have a shorter lifespan. Usually we're probably going to shoot for like 30 minutes to an hour lifespan on the access token, and then like few days to a few months on the refresh token, depending on the outlet or the end client, really. So that's great. And what we did to prove that we can do it is we can run our Suave Keys API, which it's all just going to run through this one API. We've updated Windows to bring you a brand new browser. Is this a joke? Am I getting edged right now? All I did was say run. Give me Chrome. Stop. I can't even exit it. What is this? Microsoft, you gotta chill. Oh my god. Stop. Just get me out of this. Look, I love Edgium, but I'm literally just trying to run my code in Chrome the way I have been. But whatever. So what we have set up is we have the ability to create a user, right? So sign up. Email, password, that's all we really care about. So we created a user on my local host, and then we can authenticate against it. So we take the client ID and client secret. These 2 values come from our auth client entity, right? So it's got to be this ID and this secret. So we're going to have control over who actually gets to sign into our app, or what application they can use to sign into it. So for example, we'll have a different auth client set up for like the Alexa skill, the Google Action, the desktop app, the web app, like all that stuff. We'll have a different client. It'll be nice too for us to be aware of, like, and provide to our users, like, hey, you signed in on like September 1st from Alexa, and you also signed in on September 2nd from desktop, and like if you see something that's sort of out of line from what you'd expect or what you were hoping for, you just rip it out, kill the refresh token, and they're signed out after the access token is gone. So we have the ability to actually authenticate, and with grant type password. So for example, if we have, it's like user@example.com, and we have a password of like grant type password and the password of like test123, right? And then we got to pass in the client ID, client secret. We get a refresh token back. Get out of here. We get our refresh token and access token. Our access token we can then throw in our bearer, our authorization header with the bearer prefix. That way we can tell our server that we're authenticating. And then we have a test endpoint here that basically, if I try to hit it now without signing in, throws me a 401, meaning I'm not authorized or I'm not authenticated, basically. And when we do authenticate and we pass the right bearer token up, that runs through our authorization validation, which we've set up with ASP.NET. So if I just go to this authentication controller, all I had to do is throw this authorized attribute on this endpoint. So this is that HTTP GET endpoint for test, the same one that we just hit right here. So once we do pass the bearer token, this will do all the checks to actually decode the token based off of the key that we have on our server, and be like, hey, we have all these claims in here, which is how we're now able to do things like get their ID. And this user ID that we get by pulling it out of this claim, that's what we're returning here. This is going to be super, super valuable for us to be able to do things and check against like your profile and your preferences and your actual keyboard settings and things like that. So that's all we need to actually pull out of it. Now, we've got 2 grant types supported, password and refresh token. The thing is about that is that password is sort of not kosher, if you will, and it's not super secure. The reason for that is that it allows someone to build their own user interface, their own web app, their own mobile app, whatever. And if they can basically fake being my client, then they can actually start harvesting people's passwords and stuff, or do whatever they want. So, for example, because we just have the auth client, these IDs and secrets, these need to be on the actual end client as well. So when I create this registration for say my Alexa skill, I need to actually register this with Voicify. If I create it for the Android app, like to the ability to sign in from the Android app, this ID and secret needs to be available in the Android app. And for those of you who don't know, you can just take someone's Android app and decompile it and reverse engineer whatever their code is. So there's things out there like ProGuard and stuff like that to help us out with making sure that not all of our secrets are taken. But that's obfuscation, and obfuscation is not security, and therefore we need to actually protect it. So OAuth has a couple specs that we can follow to help with this. There is the sort of deprecated, I mean, it's not technically deprecated, it is within the OAuth 2 spec, but there is implicit grant flow, which is actually like basically the same as password. Basically the same as password grant type. Then there is Auth Code grant flow, which we're going to start exploring today. And then there's like what is it? It's Pixie. So PCKSE, I think, or whatever that is. I think that's right. You're one of the people that actually yeah, I have. I've implemented OAuth a few different times. Not in a long time, though, admittedly. So this is going to be fun to sort of re-explore. Even outside of Suave Keys, I have some stuff I have to do to support OAuth and some other projects I'm working on. So it'll be nice to just have this set up, and then I can, copy-paste code from Suave Keys. And other people can, too. All this stuff's going to be up on GitHub. So this is basically like enforced hash validation of client secret. And things, so, client secret and friends, we'll call it that. So basically Pixie, right, that's the pronunciation of this anyway, according to actual Oauth Spec, is built on top. It's like extra stuff on top of Auth Code grant flows. So like these are the official types of flows in OAuth 2.0. And technically both of these are supported by Alexa and Google for account linking. So to take another step back, when we look at these types of authentication, right, web client is like the normal thing. Like this is where we actually need to take in their username and password. This is where we have to trust ourselves. We got to validate the browser or the origin from the browser and everything else. But the conversation or voice channels, these go through a process called account linking, where it actually pops up the UI for the web. You get the access token back, and it basically keeps it for you and can do all the refresh and stuff for you if you build to the spec. And then for mobile, we could, if we did implicit grant flow, we could build the UI in the mobile app, and then have that actually take the user's password. But if we're going to implement Auth Code grant flow, we might as well not do that. And basically the only place where you actually sign in, where you actually enter your email and password, is in the web UI from the Suave Keys website, where we'll be able to validate the domain and all that. So basically this one will actually pop this open to sign in, and this will take care of it. And then our clients will pop open a browser, sign in, handle the redirects and all that. And basically this actually doesn't even become the API. These are like one and the same between the web client and the authentication API. They're going to be on the same server. They don't technically have to be, but they should. So let's get started with the OAuth spec. What I want to do is close this, and we'll pull up Auth Code flow, and let's pull up the actual grant type. All right, cool. So we're going to look at spec sheets and talk about it and diagram basically what it looks like. So I'm gonna just shamelessly paint this stuff out. So right now we've got password flow, which is like user. Look at that beautiful user. User gives email and password to client, and then client passes that off to Suave Key server, SK server. Now, this is fine when we have total control over the Suave Key server. Zoomed in a little too much. This is fine when we have control over this and this. The problem is basically that this can become compromised, right? So this can get attacked and faked and mocked and all that, and then people can pretend that they're Suave Keys, and they wish they were, but they'll never be Suave Keys, and therefore we got to stop that. So what Auth Code looks like, if I can remember right. No, don't save that. So man, give me my paintbrush. Auth Code. I hope this is the quality content you all come to this stream for, is watching me use Microsoft Paint to do architecture diagrams. Okay, so Auth Code, we've got our user. Hello, user. User goes to client, but provides nothing. They provide a request to sign in. We'll just call it request to sign in. This is our client, just like it was before. Except instead of them actually giving the username and password to the client, they just go, hey, let me sign in with Suave Keys, please. And then Suave Keys goes, okay, here's the UI. So we got SK UI. And then the user works directly within the Suave Keys UI to sign in. Now, we can control this, like 100%. You can't fake this if we do it right. Then Suave Keys UI talks to Suave Key server, SK server, and goes, hey, they signed in. SK server goes, you did it. Except we don't just return to the UI here. So that's not actually what's going to happen. This is instead going to redirect to the client and pass an auth code. Auth code is basically a randomly generated code that we can take, and it can be hashed with a bunch of stuff. I'll get into the hashing stuff. Let's just talk pure auth code. Suave Key server sends the auth code to the client via redirect in the URL. So we basically will pass, they have to register a URL. We pass the auth code in that URL as like a query string param to the client. The client then goes and passes the auth code back to the server after it does some validation, which we'll get into. And then the Suave Key server goes back again, and now we've got tokens. So the idea is that you trade in auth codes for tokens. That's the gist of it. You say, hey, let the user sign in. Suave Key server goes, hey, user signed in. We trust them, and we trust the app that you came from, so here's your code. And then you go, okay, here's the code. I confirm that it came back. And then the Suave Key server goes, okay, we know that you came back from the right place because it's the place that we have registered that we sent it back to. And you did it fast enough and it didn't time out. So here's your tokens. So we have to do some validation here on each step. So what is this whole Pixie thing, right? Because this sounds pretty secure. Not bad. We send an auth code back, you send it back to us, we say you're good to go. The problem is that this validation step that I was just talking about of like, we sent you an auth code, and so you hand it back and we give you tokens, technically has a little bit of an attack surface to it, where we can't guarantee that the client is the client that originally sent the request. Technically we can't, because we can say like, hey, we validated the origin, but you can fake an origin without too much effort. It's just an HTTP header according to our server. So for example, if we said, here's your auth code, and then somewhere in between we've got an evil pirate, right? So we've got evil, not suave pirate. Evil pirate, very different. And he's got a hook for a hand. And pirate goes, I'll take that. And then pirate sends it back instead. We don't know. Like, pirate can be like, shh, I'm client. Don't worry about it. I'm the real client. Just have Dan sitting in Starbucks. Yeah, exactly. It could be anyone, not just Dan. It could be evil Dan, or just malicious Dan, or pirate Dan. But basically, let's say pirate Dan says, I'm definitely the client. And so our server goes, yeah, you're the client. Here's your tokens, right? And then we have tokens. And it's like, oh shit, that wasn't supposed to happen. Now Pirate's got my tokens. Now Pirate is actually Good Dan, and Pirate Dan became Good Dan, and that's the attack surface that is technically exposed with pure auth code grant flow. Now, that was like the spec for like a long time, and like this was just the issue. Like when I first started implementing OAuth 2 is when we just skipped from 1.0 to 2.0 in the spec. There was like a bunch of patches in the 1.0 spec, just like we have patches in the 2.0 spec now. And basically people came up, like there wasn't this auth code grant flow before. Like literally not that long ago, every request was sending passwords. Like basic auth was a thing that like everyone did. And it's just like, yeah, I'll just encrypt this password and it's good to go. Until people were like, oh, I got your encryption key. Now I'm you and I'm Pirate Dan. And it was like Pirate Dan had a way easier time, like literally just 10 years ago, if that, with like some of the standards in authentication. Now, Pirate Dan can still be Pirate. Like Pirate Dan still has a job if we just implement this. Pirate Dan or Evil Dan. Oh my gosh. Can we take a sec to talk about the fact that Pirate Dan is out there hacking all these Twitter accounts? For every dog picture you send me, I will send 2 back, and that I probably can promise. That's an official tweet from me. I'm not validated or whatever, verified, but if you send dog pics, I'll send dog pics back. So anyway, Pirate Dan still has a job. First of all, Pirate Dan still has a job because so many people are implementing bad authentication. So what we want to do is we want to put Pirate Dan in a different boat, and we want to just send Pirate Dan away from Suave Keys. Pirate Dan might try to come to Suave Keys, and he might try to pretend to be Good Dan, but we want Pirate Dan to starve. That's what we want. We want him to keep trying until he literally gets hungry and dies. So let's put Pirate Dan out of a job, and the way we do that is with Pixie, whatever it is, PCKSE, Pixie. What if I offload Auth to third parties that have multi-million-dollar... yeah. Yeah. The problem is what happens if one of those companies becomes compromised? You've got no control. Just saying. And we were originally playing around with trying to do, like, letting identity do some of it, but it just became a mess. Plus, this will be nice and educational for people, and I can pull some YouTube videos out of this and teach some folks how to implement OAuth. This diagram will just be the face of OAuth going forward. It'll be like, we'll have this slogan of like, hashtag starve Pirate Dan. Oh, I'm running out of room. Starve Pirate Dan. People will chant in the streets as they watch this YouTube video later of me struggling to draw in paint. Yeah, that's true. Everyone gets compromised. Even Pixie is technically not perfect. But anyway, the idea of Pixie is to actually let the server be aware of the client and to do some extra validation stuff. So what Pixie does is, if I remember it, I'm literally going to go read the spec after this, and we're going to be like, all right, how smart was Alex with his Pirate Dan drawings versus like what is in the actual spec. But the goal of Pixie is to let Suave Keys server basically validate for as certain as we can be that the request is coming from client and not from evil Pirate Dan. And the way we do that is basically let the client actually send information up in the very first request to the UI request to the server and implement that with a hash. So they're going to basically hash a value, and we go, okay, here is your hashed value back, and then the client is then able to like basically unhash it and validate that the value is the same. And if it's not, they get to back out. Because like this validation we do on the server side, this gives Suave Keys server the chance to back out of whatever's happening if it needs to. But client doesn't even know that it just got pirated and that it got hijacked or whatever. So this gives a chance for client to do some extra stuff. Basically, they hash it, send it over, we send it back, they unhash it, or we validate the hash against some key on our side. So we do have an extra step here. Then we send it back down, and then they validate the value. That's basically the gist of it. We just like pass a salt and hash around, or a salted hashed value. And a lot of times people will implement that with like a random thing, like, hey, literally just send us a string and make sure that the same string is there when it comes back. Make sure that someone didn't, make sure there wasn't like pirate number 2 over here. We'll say pirate Alex. Pirate Alex is going to have a hat and 2 hooks. It's got to have a feather coming out of it. This is pirate Alex. We want to make sure that client doesn't send anything to pirate Alex. So we stop this stuff and we stop this stuff by basically letting these two actually be aware the whole time that they're sending stuff, by just basically exchanging value. So like client sends some stuff, we validate it, we send some stuff, client validates that they got the same thing back that they sent originally. So like I was saying, some people will do that with like a random value. Like they'll require you to send like an extra query string param when you set it up. Others will say like, look, you send us everything in your query string, like the redirect URI, the client ID and client secret, stuff like that, and we'll send it back down with the hashed version, and you rehash that and then validate it. And I haven't decided which way to do it personally. Maybe we'll just feel it out. There might already be some tools we can make use of as well to do it, but basically it's like a SHA-256 hash. That's the standard. But let's actually start to look at it. So what is the OAuth 2.0 authorization code grant flow? Auth.net is taking me to Okta? Dang. Here, we'll do this. All right. So request parameters, we need to take grant type, we need to take code on the way back. This parameter is the authorization code that the client previously received from the authorization server. The redirect URI, which is possibly required. If you're doing Pixie, this is, I think. Client ID is required, but you'll notice there's no client secret that's sent up anymore, because that actually needs to be used for other stuff but the idea is that you only need the client ID, and all of the redirect stuff basically takes care of the rest, because the whole point is like if you have the client secret, you can do some fishy stuff with it, and it's too easy to get the client secret nowadays. You can't just store it confidently. So let's do this. Oauth Auth Code grant flow. I want like another diagram that's not mine. Images. Some of these look more complex than others. I'm not sure why. eBay. Okay, eBay's diagram for implementing eBay's OAuth. So resource owner is basically client, right? Or application is. So talk to the application. It requests an authorization code. Could it have something to do with the fact that the first thing people do is copy the sample and then check the keys in source control? Yeah, exactly. Like literally, like passing keys around is so easy. You'll get them stuck in source control. You can, if you have it in like a mobile app, you can pull it down. If people just like have it in their JavaScript on the web app, like you can just inspect the code. You can literally just go to the resources on the page and be like, oh, look, there's a little file here that says keys.js. Let's see what's inside. Oh my God, client secret. And then, like that's the stuff we just can't have. So no secrets. Only the server gets to know the secret, and no client code gets to. So request an authorization code. The user then actually signs in. So this is that key, right? The application says, give me auth code, please. And the user has to sign in. Once the user signs in, the auth code's passed back. It's exchanged for the access token, and then you use the access token in subsequent requests. What this diagram doesn't account for is the Pixie stuff. So like this whole back and forth, like that's what all this stuff, every time I say it, there's a little pirate down. That's what this stuff is, this sort of like 3-time back and forth. So far so good. So far I remember how to do OAuth. But this isn't talking about Pixie, and I want Pixie. Let's see. We might just need to look at Okta's thing. Technically, we don't need scope. State, that's the one that people use. The application generates a random string that is included in the request. It should then check that the same value is returned after the user authorizes the request. This is basically the Pixie implementation. And I forgot, that's the query string param people use. So they'll either use state as the hash, or they'll use like the whole query string, like from here, including the question mark down. I've seen it done both ways. Redirect back, yes, so we need to redirect back with the code and the state. So like if this state was sent up, like they're using in this request, they pass up this, we pass it back down, and then they need to, it's up to the client app to make sure that we pass that back down, is the gist of it. I don't really know like how secure that is, because like you could just interrupt this request to the server and be like, oh cool, nice little state you got there, and just send it back down. So like, so there's still technically an attack surface in OAuth, but it requires a little bit of weirdness, and one of the benefits of doing only Auth Code is that your users become comfortable with the one place they sign in. There's not like a mobile UI that you sign into and like a third-party UI. Hey, thanks a bunch, Dan. Thanks for stopping by, dude. I'll catch you later. So there's one UI and there's one browser, and therefore they can learn to trust it. So like you can't fake being the server and fake being the client. It's another way to kind of implicitly get around the attack surface. But that's the gist of it. Yeah, so Auth Code is best when used in web and mobile apps. Not sure where else you're signing in when you don't need this. I guess technically if you're serving up the UI on the same server like we're going to do, and that's the only place you authenticate, you don't really need this. That's where we'll actually do the password stuff, but we'll get there. So has an extra step for exchanging for the access token. It provides an additional layer of security not present in the implicit grant flow, which this one is like, send me your password. All right, so here it is. If you're using an Auth Code flow in a mobile app or any other type of application that can't store a client secret, although they say can't, that really shouldn't store a client secret, but they totally can, and they totally do. Yikes. Then you should also use the Pixie extension, which provides protections against other attacks. So this one isn't actually talking about Pixie, I think, technically. Sponsored by Okta, that makes sense. So this is from Oauth.com. Okay, Pixie is proof key for code exchange. Pronounced Pixie, see? I knew it. Extension describes a technique for public clients to mitigate the threat of having the authorization code intercepted. The technique involves the client first creating a secret and then using that secret again when exchanging the authorization code for an access token. So basically, like, you send up some secret in the initial request to get the authorization code, and then you need to be able to send it again when you actually get the access token. This way, if the code is intercepted, it will not be useful since the token request relies on the initial secret. So we need to actually look at this. Full spec is available in this RFC. I mean, we can open it up, but I hate reading the actual RFC. This is like the actual spec doc. Internet standards track document. Oh my god. Yeah. Oh, look at this diagram drawn out with ASCII characters. Legitimate OAuth 2 app. Auth's request. Malicious app. Oh no, it thinks it's the server, and now it does the interaction with the server. Right, that's basically Pixie gets to block this section of things. This troublesome little sucker. But I don't want to read through that because it's kind of gross. Authorization code exchange. We'll close that. Okay. When the native app begins the authorization request, instead of immediately launching the browser, the client first creates what is known as a code verifier. So that's the secret that they've talked about. This is an on-the-fly secret for just this authentication request. This isn't like the client secret that we've talked about storing before. This is cryptographically random string using uppercase, lowercase letters, and digits, and punctuation characters between 43 and 128 characters long. This is oddly specific. I'm sure there's a reason, but that's fine. Once the app has generated the code verifier, it uses that to create the code challenge. For devices that can perform a SHA-256 or SHA-256 hash, the code challenge is a base64 URL encoded string of the SHA-256 hash of the code verifier. So basically, you take your code verifier, you generate a random string, then you hash it using SHA-256, then you base64 URL encode it, and you pass that up. Clients that do not have the ability to perform SHA-256 are not permitted, are permitted to use the plain code verified string as the challenge. That's weird. I don't know who wouldn't be able to do that. I guess technically if you don't have a powerful enough processor, you can't. I think it requires at least 32-bit. So maybe if we're trying to authenticate from like a super small microcontroller, like if we were to try to throw it on the Arduino itself, which I think is only a 16-bit processor. What kind of processor you got in you? It might be no, I don't think it's 32, but maybe it is. Then this I don't think would be able to do. I think you do need at least 32 bits and a big boy CPU. So now that the client has a code challenge string, that's the whole thing, the hashed and URL encoded string of your random string, it includes that and a parameter that indicates which method was used to generate it, plain or S256. Oh, okay, so you can tell us if you're doing plain, along with the standard parameters of the authorization request. Okay, so it passes up this code challenge and the method. So we need to basically accept all of these as query string parameters in our endpoint. The authorization server should recognize the code challenge parameter and associate that with the authorization code it generates. So we have to basically store, when we create an auth code, we have to actually hold on to it. So we can't just like keep it in memory, because technically we could have multiple instances of a server. So when we generate an auth code, we're going to generate it just like we did with our refresh token. So we'll have a table for auth codes, and like they'll expire after a certain amount of time and all that stuff. And we need to associate this code challenge with it, so the full thing. So we recognize it, we associate it with what it generates, either store this in the database, along with the auth code, or if you're using self-encoded authorization codes, then it can be included in the code itself. The server returns the auth code as normal and does not include the challenge in the data of return. So we hold on to that. Then, if you get an error, then we can send, like, you need things, right? And then basically what happens is when we get the next request up to exchange the auth code, right? So our server is going to get this code challenge. We're going to hold on to it. We're going to generate an auth code. We hand that auth code back to the client. So if we look at our beautiful drawing, we hand this auth code back. Pirate Dan can technically take it, but if he tries to send it back, we'll be like, no, you didn't have the original thing. So because client sends the original thing in this full request, right? So now this is going to include the challenge, or we'll call it the chal. We get the challenge in this one. We send the auth code, and then this one they have to send the auth code plus the challenge back. So only this client is aware of the challenge, and our server is aware of the challenge, which means that Pirate Dan can't intercept the auth code on the way and send it back, because if they try to send it back and say, shh, I'm the client, here's your auth code, we're going to be like, whoa, where's your code challenge? You didn't send us a code challenge. And then they'll be pissed, and Pirate Dan will starve. So we send back, the client's going to send back the auth code and the challenge, and we then actually send back the token, and we're good to go. So that's what we got to do. So to implement this, we need to handle like redirects, and we need to have a UI for actually signing in, and we need to have like the auth code stuff set up. So we can start doing some of the auth code stuff, and then we'll implement a very basic UI. We'll make it pretty later to actually let someone sign in and do the redirects and stuff like that. Cool. So let's get it started. First things first, rest in peace, Uncle Phil. Just kidding. We're going to create a new class in our entities, and we're going to call this Authorization Codes. So just like our refresh token, this is going to have an ID, prop string ID, and we'll generate it GUID.new GUID.toString. We're going to have a string called Auth Code. This is the actual value, up and down. we're going to have a string challenge code, and we also need the auth client ID, so I'll have string auth client ID. I guess we shouldn't call this codes, huh? It's just one code. And this is redundant. We'll call this code. That's the one we want. We have an auth client ID, which means we'll also have the navigation property of our auth client itself. So we'll have auth client, and we also need date time created date, and we'll also have date time expiration date. So basically, this is going to be used for validation. This is going to be used for validation, and basically everything else is pulled from this. So some other stuff we need to do. We need to have valid redirects URI stored as a string. So we're going to have prop string redirect URL used for auth code grant flow. So the reason for that is that when you try to authenticate, when a client says, "Hey, Suave Keys, it's me. Let me sign in with this user," they need to give us the redirect URL for us to send all this info back. So like when we send back the auth code and like in the end the access token as well, then we need to send those back and validate that, hey, if you requested us to send it here, are you allowed to send it there? So we'll have auth redirect code, auth code redirect URL, and then we'll have string token redirect URL used for validation. So technically we don't need to like take this URL and like that's what we redirect to. They're gonna send us the exact URL, but we need to basically validate the host name. URL host, that's what we want. We don't need like the full URL, we just need the host name. So if like this is gonna come from an Amazon one for the Alexa stuff or a Google one for all the Google account linking stuff, these will be two values that they'll provide when we set up account linking. So that's the dealio. Okay, so we've got these on auth client. We've got an authorization code with ID code challenge, auth client ID, created an expiration date, and then we've got that linking to our auth client, which means now we can create a migration. So let's see if this will actually be nice to me this time, and let me do it from here. So if we go to infrastructure data and migration, auth code. Term add migration's not there. Okay, so we got to do this from PowerShell again. Projects, Suave Keys. Let's see, where were we? We're in source, Suave Keys. Can I make this bigger? Oh, I can. Cool, now you guys can actually see this. Ooh, big. Alright, we need to be in the API, or do we need to be in core data? I think we need to be in the API. So we're going to go to cd suavekeys.web. Yes. And this is where we want to .NET EF help. Let's see if we can figure out what we're supposed to do. So we want to say migrations add .NET EF migrations help. I got to remember the thing. So we need to give it a name. Add dash help. Let's do this. We're getting closer. Add help. What can I do from here? So we need to choose our project. Yes. So this is where we're going to set the relative path to our infrastructure data project, because that's where our migrations live and that's where all of our data stuff is. So that's cool. Let's do this. .NET add. We need to give it a name, right? What's that called? Is that just the default param? Oh, name is the default. So we'll say we want to add Auth Code. Ooh, before we do that, totally forgot. In our database context, we need to actually add a table here for Auth Code. Prop db set authorization code, authorization codes. All right, there we go. Let's make sure we build too. Okay, so we're built. now we can add auth code, and we need to set project to /Suave Keys infrastructure data /Suave Keys infrastructure data.cs proj. Did it just like horizontally scroll on me, or did I lose it? Hello? It's like, all, what is this? Look at that. I got like spare E's down here. What's going on? I'm just gonna hit enter and see if that did it. Did it do it? I don't know what the hell is happening right now. My machine is heating up. Hot to the touch. Did it do it? Did I get a migration? Hello? PowerShell, are you there? Oh, there we go. Okay. Weird. Targets from .NET Standard, not runtime associated. What are you talking about? This is literally what we just did last time. It's like a different. Do we have to go into infrastructure and then do web? Hold on. Let's get help again. Framework project, startup project. That's what we want. So we need to set startup project and project differently. Okay. Okay, so we want project there, and we want -s to be suavekeys.web. Yeah, you can run it on a library. Yeah, I just couldn't remember. I need to have it like set one as the default and then one as the actual startup project. And basically, I need to have this set as the startup project, which is our actual API, but I want the project where it is to be our .NET Standard one. Maybe that's not right. Where's my CS proj? Hold on. Let me just look at this in my actual UI here. Suave Keys, source, Suave Keys, web. What? Is that the wrong one? Oh, it's that API. I'm an idiot. That's why. We're in the wrong freaking project. Where did Suave Keys web even come from? Alright, here we go. Let's try this. Not .web, we want .api. I think this should work. So, yes, go. Give me my migration. There we go. Now we've got auth code. We should see we've got a table added for authorization codes. We've got updates to our auth clients table to add those new stuff. And on the way down, we basically drop those columns and drop the table. Cool. So now we can call .NET EF database update, I think. Did that do it? Go. There we go. So now if we run pgadmin, we should be able to see our new table. Alright, first step's done. We've got a table to keep track of our auth codes and such. Now we actually need data logic and business logic. Do I use SonarLint? SonarLint? SonarLint. Yeah, SonarLint. No, I've never even heard of SonarLint. Now you got me looking this up. SonarLint. Improve quote column. Add the NuGet. Fix issues before they exist. Is it just like it's just more IntelliSense, just more linting? I mean, I'm probably good for now, because I feel like Visual Studio's IntelliSense is usually good enough for me. I definitely appreciate the suggestion, though. Oh, here, sorry. I don't know why these are getting blocked. It's more than that. Maybe for analyzers. Interesting. Yeah, I've never used this. I might just try this out separately. That way we can at least just keep moving here. Okay. So we've got our models updated. We've got our database context updated. What we need is a repository method. Gotcha. Cool. All right, we need a repository for actually accessing our auth codes. And then we need to actually start to build the flow of doing the exchange. And we can do that all in our authentication service to like handle that. And basically we'll have like the business logic side of it, and then we'll set up the UI side. At least in my head, that makes sense. So we need some transfer stuff for authentication, not just token response anymore, and not just this authentication request. We need an auth code request. So auth code request is what we're going to be using. Let's see, input model for requesting an auth code. So this is the first model that comes up that will represent like the redirect URL, their code challenge, and stuff like that. We'll then have an auth code response, and then we'll have a auth code token request, and then that will end up returning the token response. So auth code response, we'll make this public. This is going to be response model for returning an auth code after a valid request. And then the auth code token request is basically that third trip. So looking back at our pirate drawing, the initial request here with the challenge, that's our auth code request. We send down the auth code, that's the auth code response. They send it back up, that's the auth code token request. And then we send the token back down, which is token response, which we already have. So this is going to be request with an auth code to get an access token. So now we can start to basically stub out the methods we need in our auth service. So if we go to our interface for our user auth service, we're going to have a task of auth code response that is grant auth code, and that's going to take an auth code request. And this is validates an auth code request and returns an auth code response. In the end, our controller will be able to handle like doing the redirect and stuff like that. This is strictly the business logic side of it for like doing the validation, being like, hey, you're good to go, keep going. And then we'll have the task of token response, and that will be authenticate authorization code, and that will be an auth code token request. So this is going to be authenticates an authorization code request, validates the code challenge, and returns the tokens. So now we can basically stub some of this stuff out and go from there. I'm going to take just a 2-minute break here, a little bio break, and get some more water and probably some more coffee. So I'll be right back, and then we'll start implementing this stuff. And then after we have that, we'll implement the UI, and we should actually be able to start going. So, I mean, ideally by the end of today, in the next 2 hours or so, we can try to authenticate an actual like Alexa response or an Alexa request, which would be cool to see that come all the way through. So cool. I'll be right back. Give me like 2 minutes, get some more liquids, and we'll carry on. All right, we're back. I've got more coffee, and hopefully it'll help me wake up and be able to actually write some decent code. Cool. So where we left off about a minute and a half ago is we're stepping out some of our business logic for doing the Auth Code grant flow, and we're going to implement that business logic now, and then add our interface and controller and stuff in front of it and just sort of compartmentalize some of that stuff as well. So in our user authentication service, we'll notice, oh my gosh, it's no longer valid. What are we going to do? So let's start implementing some stuff. All right, I want to get these in order. Basically, oh, come on. Here we go. In the Authenticate Authorization Code, we need to actually, we need to make sure that the request is coming from the right client and the right origin that they're allowed to send the request from. And then from there, we'll be able to actually do the UI stuff and then do the login and return it back. So there's a couple of steps here actually that we need to take care of. But and then the grant auth code is the one that comes first. So that's that one. This is the one to actually give tokens, right? So this one, give token. This one is give auth code. And that's how we're separating everything. So for the grant auth code side of things, I guess this isn't even so much on the auth code side. Technically, we need the user to log in here first. So the auth code request will actually have the username and password as well. There's actually really 3 steps here. Hold on, let me just write this out. So we've got request to auth, which takes in client ID. This takes in the code challenge. And like scopes and stuff, and technically we don't really need scopes because there isn't a scope for our user account other than like getting an authenticated environment, and we're in control of the end clients anyway. So really we need the code, the client ID, code challenge, and origin. Then there is the request to for Auth Code, which takes in those same things, code challenge, origin, as well as the actual email password. So we have to, there's validation steps here, then we actually authenticate the user itself, and we can double down on the validation. And then there's requests for tokens, which takes the code challenge and the auth code. So really we need 3 methods here. So we have like request for authentication, which will basically just be like yay or nay, and that can return a bool. And we have the actual granting of the auth code. So we have task, let's just say bool for now. We can just return true or false, valid or not. And we want to request authentication. We'll have a auth code. Let's call this auth code request, and then this will be, the other one will not be auth code request, but we'll have another one. Rename auth code sign in request. Fine, we'll take it. Auth code sign in request. That's just how we'll separate who's actually authenticating when we get to this part of the business logic. So this is really request ability to authenticate user. That's like first step. Like we need to do this before we present the UI. This is after we present the UI. This is the after we've redirected a whole bunch of times sort of thing. So now we need to actually go back to our service. Where did you go? Sweet, sweet service. I want to put these in order of the things we got to do. Where is it? Why is it down here? Request authentication. That's first. Step 1. This is, can we show UI? Okay, so the way I usually like to sort of write out this business logic is I like my business logic being as flat and like step by step as possible. And the way I kind of enforce that in my head is writing out what those steps are, especially when it comes to like validation, then execute something, then build something, then return it. Like all that biz logic, writing it out step by step and then implementing it underneath also makes some like self-documenting code. Technically, it adds more comments than you need, but it helps me with writing out the steps, and that way someone can come in and just read the logic the way that I thought about it as well. Okay, so to request authentication, we need the we need the code challenge, and we need to validate some stuff first. So we're going to say validate client ID, validate client origin. We need to then create that's it, right? Are those the only things we need to validate? That they are a valid client and that they pass in the right origin, or it came from the right origin? What is this? Oh, I didn't need eBay. Right? Is that all we need? Grant type. Validate grant type. I mean, technically, that's gonna come somewhere else. Validate response type. Is that what we send down? No, yeah, that's what we send down. Client ID, redirect, state. I mean, we can technically validate state, but we don't need anything. Oh, actually, we just need to keep this and make sure we pass it around. Oh, we also need code challenge method on the Auth Code entity. Oh, I left the file name. Alright, so we should actually add a few more properties here. We want prop string state, although technically I don't think we need to keep it. We want prop string, what is the official name? Challenge method. Challenge method, and this is either plain or SHA 256. I think, right? Those are two values, right? Plain, yeah. Cool. So we'll have to run another migration. That's fine. We can, now that we actually have it set up right. We'll call this one Auth Code new properties. Is it doing it? My computer's spinning. Good sign. And we'll update. I need to put verbose on here so I can actually see what the heck is happening. Alright. We've got those set up. Cool. Cool. Back here. Validate that. And that, I mean, that's really it. That's all we need to validate in this first step before we say, yeah, you can go ahead and show the client. Right? Validate method and response type. No, they don't even do that. Validate grant type. Validate challenge method. Validate grant type, maybe? Okay. So to validate the client ID, let's go get the client. So we have var auth client equals await auth client repository, and we have a find by ID and secret, but we're also going to end up needing a find by ID, and we'll have a request.client ID. So we'll end up going and fixing this stuff later. Actually, we should probably fix it now. So we need this set up with this find by ID. So if we go to our auth client repository, we want the ability to find it by just ID. So we can copy that, just say find by ID. And we need our request model to actually have the client ID on it, because otherwise we can't actually grab it. So now we know we need that. So we're going to pin this, and we're going to pin this. So we need a prop string client ID. We need a prop string redirect URI. and we need a prop string challenge. Right, and those are the things we're going to validate, and grant type. Sure. String grant type. All right. What doesn't this like? Oh, we're not async. Duh. Okay. We got an auth client. If auth client is null, we're going to throw an exception. Again, like we talked about this last stream, but I'll end up refactoring some of this stuff into the result pattern, but I kind of want to do that separately and talk about it. For now, we'll just toss exceptions around. And basically all of these exceptions are placeholders for results. So we'll throw a new exception and say invalid client. Easy. All right. Now we can validate the origin. So we want to say if auth client dot origin. What do we got? We need to validate the redirect URI. Auth code redirect URL host. We can say if request dot redirect URI to lower. Actually, we should do this properly. We should do this. Actually, yeah, we can do starts with. If the redirect URI dot to lower dot starts with our host, because we want to ensure that we actually pass the whole thing. If it doesn't start with host, we're going to throw a new exception and say invalid redirect URI. Easy peasy. All right, let's validate the challenge method. If request dot challenge method, we need to add that to our auth code request. String challenge method. Oh, actually, you know what? We probably don't need to validate this. Either plain or S256. I should actually change the comment on that. If the parameter is omitted, the server assumes plain. So actually, we don't need to validate this. We should assume plain. Perfect. And then otherwise, we want to say if request.grantType does not equal, I think it's code. Throw new exception. Actually, we're not going to throw here. We're just going to return false. We already have this bool set up. No. I like having the string errors. Just say invalid grant type. This is kind of dumb. All right. Otherwise, we return true. We're good to go. We're good to show the UI. Validated all your stuff. You're good to go. Actually, we need to validate the origin though. Because technically, if you got access to their client ID and redirect URI, you could fake it. So we also want origin. Does that mean that our authorization code entity also needs an origin? Not the redirect origin, but the original origin? Or sorry, not the authorization code, but the auth client? Auth code redirect, yeah, alright, we do. We need one more property. Origin host. Host origin or origin host? It doesn't matter. We're going to make another migration real quick just before I forget. Build failed. Oh yeah, we're still in the middle of some stuff, huh? Wait, actually, why did the build fail? Oh, we added, we need to add the repository method. It doesn't like us otherwise. Alright, that's fine. Copy, paste, get rid of this. Get rid of this. Bada bing, bada boom. Easy. Now give me that migration. Ugh, I didn't change the name. New properties 2. And now can I update? There we go. Run the update. All right, in our auth service, we want to validate client ID, validate client origin. Now this is actually validate redirect origin. We can basically do the same thing. oops, don't need that. Instead of redirect URI, we'll say origin. Does not start with origin. Invalid origin. Look at all that validation. Okay. This one we want sign-in request, which means we need to update our interface too. Grant request. That one takes that one. Cool. Okay, so basically at this point we've got all of the info we need and the actual username and password. So again, writing out our auth stuff, we want to validate username and password. We can basically run this validation again. Rerun request validation, build response. Okay, so to validate username and password, we can take what we did up here and say is password match. Right, we got this. Oops, we want to underneath this comment. So the password match. Oh, we need to find the user first. So we'll say var user. I'm just going to copy it from above. So we already did this. Ba 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 ba. Ba 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 ba. Ba 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 ba. All right, now we need to actually set up some of this stuff. So on this one, we need username, password, and we need everything in the auth code request. So I'm going to actually do some gross inheritance, and then we'll add string username and string password. Basically, this method should never actually have an exposed endpoint that's exposed via the API. It should only be able to be hit from our origin and be the postback of the form. But anyway, we got this. We got is password match. So at this point, the user is signed in, right? So we've got that. And we'll say var is valid equals await. And we can do this request authentication, and we'll pass in request since it's inheriting now. And then if we end up returning false here, then we'll just throw a new exception. And we'll just say invalid client in general. But now we're at the point where we need to build the response. So instead of just building response, we need to say create auth code and store it. And then we want to return response. So we'll say var auth code equals new authorization code. And we can say the auth client ID equals request.id. Challenge code is request.challengeCode. Challenge method is request.challengeMethod. Created date is datetime.utcnow. Expiration date is datetime.utcnow.add minutes. And basically, we'll give you 5 minutes to sort your stuff out, and then it's gone. It's going to be expired. Let's see what else we got. We got to actually generate the code, and we have to take state. But for state, we'll leave null for now because we're not doing any. Oh, actually, we do need to take something with it. So we'll say state equals request.state, which we'll need to add. So if we go here, we want it on the original one. We'll say string state. We'll keep track of it. That way we can send it back down. Do we need to send it back down? Or is it sent back down the first time? That's fine. Whatever. And code we need to generate. Let's talk about how to generate a code. So there's some suggestions in here for generating the code. It needs to be only alphanumeric, capitals, lowercase letters, digits, and certain special characters. Period. Where is it? That's the Octoblog. This has some. I think this has some of the stuff in it. Does it? Does it? Does it? This isn't it. Where is it? We kept it open somewhere. Here it is. Here's our limitation when we're generating it. We can probably just find a library that does this if we're being honest, but basically capital letters, lowercase letters, digits, and punctuation characters, only hyphen, period, underscore, and tilde. So let's do this. C# auth code random generator. I don't really like that, to be honest. This one might actually do. Oh, what? They literally just duplicated it. Good distribution. Copy the same thing like 4 times. That's silly. I don't like that one. I don't like that either. Just convert to character. I don't like these. I don't really like these at all. Actually, these ones aren't too bad. We just have like a pool of characters that's allowed, and then we just randomly generate. It's technically not super secure because technically the random class is driven mostly off of like the current date time, and it's not awesome if I'm being honest. But that's fine. We'll take this for now. Thank you, C# Corner. Say create auth code, and we're gonna default this. What did it say? There's a limit. It's like between 43 and 128. I like 128, so we're gonna generate one that's 128 characters, and it doesn't really need to be static. Okay, code equals generate what? Oh, create. I'm gonna call it generate. Generate auth code. Bam. RNG. Alright, now we need to store it. So we need a repository, which we don't have yet. So let's go to our data, repositories. I'm going to create an Authorization Code repository, and we'll basically just add find and get by code. So we've got a public interface. We'll have a task of authorization code. Grab all them namespaces, and we'll say add. I'll take an authorization code entity, and then we'll have a task of authorization code that is find by code, string code. Actually, we need to validate against the challenge too, right? So we'll say find by code and challenge. So we got string code, string challenge. Cool. We'll do the implementation in a sec. I want to finish the business logic. So I'm going to set up some good old dependency injection. And we're going to have a private read-only of those. Give it the full name, and then just delete our existing constructor and let Visual Studio do the work. Except that it puts it all in one line, which is kind of gross. So I'm going to break these. Break. Ooh, no. Break. And break. And break. Look at all of them new lines. Okay. We got to add it. So we'll say auth. Actually, we can just say await auth code repository and auth code. Cool. Now it's added. Now we need to commit these. Do we have save changes in here? We do need save changes. Save changes async. We want to be able to just commit that transaction. So task save changes async. This will basically just be a pass-through to our DB context. But I like the idea of having the repositories handle their own transaction. That way we can actually like swap the underlying provider for this if we don't want Entity Framework in the long run, which, you know, we never know. And also for mocking, I guess. All right. Why is my delete not doing anything? There we go. All right, so now it's saved. We've got the auth code. Now we want to return the response back. From the business logic, we don't really need much. We just need the actual code itself. So if in our auth code response, I'll have a new property, string code, and we'll have state, because we have to send that back down. So that's for the client to validate. Okay, so we want to return a new of these. So we got code is our auth code to code, and state is auth code to state, and that's it. All right, recap what we got so far. We've got some validation to actually request the authentication. So before we throw the UI up to the user to actually let them sign in, we validate against the client based off what ID they send up, their origin, their redirect URL, and their grant type. Then once the user actually signs in, we actually do username password check to make sure the user is actually able to sign in. And then we recheck validation in case technically it's interrupted. Although this origin check is not really going to work if it's going to be coming back from our origin. So maybe we don't actually need to do this. Yes, we don't need to do that. We're going to do it ahead of time. And then we build our auth code response. Actually, you know what? No, I take that back. I do want to do it. We're going to be safe. We're just going to throw the origin back. We're going to put it in state in the UI and have it tossed back up. Then we build the auth code, we save it, and we're good to go. So now we need to actually be able to authenticate from the auth code and then eventually generate tokens. So like all like the rest of the stuff we do down here for the other grant types, in which case we'll end up deleting password. We'll keep it for now for testing, but this will go and we'll only have refresh token. So this like generate stuff, like this is all going to happen now. So I'm going to copy it. We'll refactor in a little bit, but I'm going to put it all the way at the end. So for actually generating the token, what we have to do is find the auth code by code. We then need to validate the code challenge. We want to validate the redirect URL. Then we want to remove the auth code from the DB. And then we want to generate tokens. And then build the response. I think that's it, right? It's like down here, that's all this stuff. Sweet. We'll get to, actually we don't want to send the user ID. And this needs to be async. We don't want that either. Oh, we do need this though. Sorry, we want this one, we don't want it in the response. Oh, that also means that our auth code needs a user ID. Play me a lick. A Jonas Brothers lick. I don't know if I know a Jonas Brothers lick, but this is the first time anyone's actually used those the social points for that. So hold on. Let's see how this goes. So okay, we got to take a break here for a sec, and I got to play you a song. I don't have any Jonas Brothers songs memorized. But how does that sound on the mic, by the way? Year 3000, I know you know it. I don't remember it. I'd have to look it up, and that doesn't count. Does it actually sound okay? I didn't know if it was going to sound really bad on the microphone when I was saying, like, oh, I'll set up this super high social points thing that no one will ever use. Okay, hold on. We'll take I keep forgetting I'm muted in full screen. I need to fix that. Actually, maybe I can fix it real quick. Hold on. I need to add... Hello? Can you hear me now? Is that better? Alright. It actually sounds okay. I'm gonna have to listen to this back. But alright, I'll give you a lick. You get like 10 seconds. You don't know the Joe Bro song? It's a little bit of one of the riffs from Lenny by Stevie Ray Vaughan. That's what you get for now. And if you try to throw another play lick at me, it's not gonna happen. 1 per day per viewer. Okay, let's get back to the code. I hope you liked it. So we needed to update our entity, if I can remember right. Our authorization code needed a user ID. Obviously, we need to actually know who the hell we're authenticating against. So we're going to have a string user ID, which means we're also going to have a navigation property here for user. And we'll end up running the migration again, but we can do that later before we start testing. So that means up here, when we're generating it, we also need to actually put the user ID in here. And we'll have user.id. Posture check. My posture's fine. Give yourself a posture check. Except like now I'm rolling over my cables. Ugh. Okay. We gotta find the auth code. That's the first thing we gotta do. So we'll say var auth code equals await. We'll take our authorization code repo. We set up our little find by code and challenge. So we'll take the request.code, which we need to set up. Oh, stop. And request.challenge. So let's add those. We're going to need prop string code, prop string challenge, and we also need the redirect URL. URI, I think is technically what we need to call it. Okay. Challenge code, yes. Boom. Async, of course. You can't await without asyncing. So technically these are going to happen at the same time by code and challenge. So that will handle our validation on the challenge side. We don't need to rehash anything. We just need to actually make sure that it's the same when it comes back. So we'll say if auth code is null, then we're going to throw a lovely exception for now. Oh, come on. Cursor, please. Exception. We'll throw the exception, and we want to say invalid code or challenge. Boom. Validate the redirect URL. So just like we did up here, when we validated this one, we need to validate the actual token redirect URL. So if we want redirect URI starts with, oh, we need to get the auth client first, huh? Oh, we have the auth client. It's on the auth code. Auth code dot auth client dot redirect URL. Oh, you know what? We should try to find the. Does the client ID come back up the second time? Client ID received when you first created the app. Yeah. That's the one I want. Oh, this is the code we need, by the way, not just code. Real quick before I forget, when we do it up here, that's the one we want, without a space. Interesting. This is saying code verifier, but the spec we were looking at expected something different. Yeah, code challenge. Wait. Code verifier matches. Oh, it's sent up as a different name on the second one. All right, we do get client ID then. Okay. I don't think they sent grant type on the first one. So maybe we need to do this validation step later. This doesn't make sense. This one. We need to do it on this one. Redirect, token redirect. Where are we? What is going on here? What were we doing? Hello? Validate grant type. Yes, now we want to validate grant type. So this needs the grant type sent up. Prop string grant type. Be gone. Okay. Invalid grant type, invalid redirect URL. we need to not just find this by code and challenge. We want to find this by client ID as well. So we'll say challenge string client ID. And therefore, we need to also pass in client ID, which we also need to put on this string client ID. Okay. So we validated the client. We validated the grant type. Now we need to remove the auth code. Like, we're good to go now. We're just good to generate some stuff. Which means our auth code repo also needs a remove. Task authorization code, remove authorization code entity. So we can say await auth code repo remove auth code. And we don't want to transact on that yet. We'll do it down here in this save changes. Okay. And we need to get the user out, which user we have from the auth code. So actually we should do this after we generate all these tokens. Oops, not there though. Down here. So we can say var user equals authcode.user. There we go. And this we can do authcode.authClientID. Look at that. So now we just need to make sure we actually have these when we go pull this down. So when we implement it, we need to do the explicit includes for EF, but we'll get to that. I don't like this senseless variable assignment, so we'll just do this. Okay, then we build a token response, and then they get their tokens. That's all there is to it. So I think that's it for our business logic. Let's just sort of smoke test this, or not really smoke test, just validate it. So first step, we get a request to do authentication. We get like a client ID, we get everything. We validate that that client's actually got the right to do it with this stuff. If it's true, show the UI and let the user sign in. If it's false, then we want to show the error, like an error. It's like, hey, you're not allowed to sign in. When the user signs in with their username and password, we want to actually sign them in. And then we want to validate some stuff. And then we want to build the auth code for them and send that down. So we send down just the code and the state. Right? So basically, these are the things. Where is it? This one? This is what we need to send down. Response type code indicates that your server expects to receive an authorization code. So we'll send this stuff. We'll send. Wait. State code challenge. No, we don't send this back. This is what's sent to us. Where's the other one? Is this it? Grant type, authorization code, the code. And the redirect URI, client ID. Yeah, these are the four that we expect the second time around. Where'd the we were looking at something with like, hey, you gotta send this back down. Maybe I'm missing something here. Oh, is it this one? Indicates grant type code. We'll send the authorization code obtained in the redirect. Complete access. Oh, this is the second time around. So the first time up, this is what's sent. This is all the stuff we get the first time. The second time we get this stuff. So we just need to send in the URL params. Where does it say what we need to send? Authorization server should recognize it, either stored in the database, blah, blah, blah. Authorization response. This is what I want. Generate authorization code. Be associated with the following client ID, redirect, user info. Yeah. Expiration date, unique ID. Yeah. Okay. Once you generate the authorization code either by creating a JWS encoded string or by generating a random string and storing it, you'll need to redirect the user. The parameter should be added to the query string. So this is what we need to send back down, the actual code and state. All right, yeah, so that is all we need. We put those, that's these two. Oh, we nailed it. Cool, so then the second time comes up, we get all this stuff, and then we send back down the actual tokens. We need to send like token type and expires in and all that stuff, and we get access token, and we can give them the refresh token. Error description, state, blah blah blah. It's like if it breaks, we can send this stuff. Ah, don't follow that. Cool. Okay. So we've got our business logic. We do need to actually build our repository. So let's do that before we forget. We need to have an authorization code repository. Authorization code repo. This is going to inherit from our base entity repository, and the type will be authorization code. This lets us do just some of the entity framework stuff more easily. And then we need to implement the authorization code. And we need to bring in the namespace. We need to generate the constructor that takes in the context. And then we need to actually implement these things. Cool. So we've got add. So we'll say return await. And we need to async this. Return await data.add entity. I made the same mistake last time. I knew it as I was typing it. Add async. Does add async return it itself? Can I just do this? Nice. Okay. Nope, can't do that. Illegal. Alright, we do that. And then we'll return entity. This will act on the reference type, so it's not going to give us a new one anyways. Realistically, we're not even using it. Alright, we want this async. And we need to do return await data dot include, and we want to include the user ID, not just the user ID, sorry, the user, and we also want to include the auth client, and then we can do dot where a dot, come on, give me link, a dot what am I doing? Code equals code and challenge equals challenge and client ID equals, or a dot client ID equals client ID dot first or default async. Boom. For remove, we want to say data remove. There is no async version of this, I don't think. Entity, and then we'll just return task.from results, and we'll pass entity back. Technically, this isn't going to be async, but whatever. All right, we got that implemented. We need to set up the dependency injection. So if we go to our startup, we want to, oh, what the? Oh yeah, I'm in the right file. Here we go. Our other repos, separate these. Services, add scoped, authorization code, boom. Now we can actually inject it. Cool. Now we can start to sort of test out this business logic. One, we can write unit tests, but I haven't set up the unit test framework, and I don't really want to do that right now. I might even just do that offline, because honestly, I don't think it would be very exciting to watch me write unit tests and set up a unit test framework with XUnit and stuff, but we certainly could. I want to get closer to actually having this set up. So why don't we do this? Let's actually start stepping through our controllers. So we're going to have a new non-API controller. So ironically, all of these so far have been UI, or not UI, the opposite. These have all been API controllers, but we do need to actually build a user interface that lets us sign in directly from this server We don't want to run that somewhere else. So we're going to have a new controller, and we can call this sign-in controller. It's going to inherit from controller base, controller base, and we'll have a route for just controller name. It's no longer an API controller, and we'll have our index one, so we'll have an HTTP GET, and we'll have a public iAction result of index. And technically this is going to take in some stuff in the query string. So let's see, what do we need to actually get from the user on the first one? That's the response. That's the second time around. Where did our first one go? Here we go. We need these each as strings. So they're going to be coming in as query strings. So we need string grant type, string grant type, string client ID. What else? What else? Redirect URI. Wait, this still isn't right. We don't want code. This is the same one we were just looking at. Let's just do this. If we go look at our service rather, this method is what we need all the stuff for. This one. We need the challenge, redirect URI, challenge method, origin, and state. The origin we'll get out of the actual request body. We don't need that, but what I'm going to do is side by side these, and technically we can make these from into a model. Realistically, if you go over like 3 or 4 params, you probably should. I just hate having to do the mappings of like these naming conventions into these in a model. I'd rather make them in the params and just map them and get them out of the way. But whatever. We got redirect URI, string challenge, and string state. So in this, oops, we already had the parens. All right, we can pull this back over to this one. We got all our stuff set up. We got our parameters. In this controller, we want to inject our user authentication service. So we'll have an user authentication service. Come on. Whoop. Give me the autocomplete, please. We'll just call auth service, and we'll generate the constructor. Now it's injected. Cool. This also needs to be an async task, since we're doing all sorts of async stuff here. Okay. So let's see. We want to just do the initial validation on this one. So say var is valid equals await auth. We want to say request authentication. So now we'll create our model, clean up the namespaces. And we can basically map all this stuff. Challenge, state, client ID, grant type, redirect, challenge method we also need. Say string challenge method, and we'll default it to plain because that's what the rules say. Challenge method, and origin will be request dot origin dot headers origin. I think I've done this before. We'll find out if we get an issue. If it's not valid, why don't we do this? Right now we're throwing exceptions, so we'll make some assumptions. We'll say to do actually check is valid, but we're going to return a view, and what I want is for this to be a model. Pass in model. Technically this will throw exceptions right now if it's not valid, so I'll say that's probably fine. And then in this case we want to return view of model. Am I missing something here? Isn't that a thing that you can do? We just want controller. Controller base doesn't have that. Right, so now we need to set up a whole bunch of stuff to actually return views and handle the form and all that. But what we can do now is have our actual post version of this. So basically what we're going to do is we're going to return a view. We'll have a Razor view that we set up that has this in the model, so it'll be all in state. And when it comes back up, we can send the model with all this stuff up to it and post it back to the same page. So we'll have a post version of this index endpoint. And when we post back to it, we'll get all of this existing stuff plus the username and password, and then we can do all the redirect stuff. So let's set up that sort of HTTP logic ahead of time. So this will be HTTP post, public async task, action result, and this will again be index, but this time we're going to have from form. Whoa, Visual Studio. What did I do? Replace property with methods code refactoring preventer. Oh my gosh, we blew up all sorts of stuff. My C# was so bad that the linter just exploded on me. Anyway, from form, we will take an Auth Code signing request. Sign in request rather. And then we'll save our response equals await, our auth service, and then we'll have grant auth code, and this will take in request. And then what we can do is basically this will throw an exception if it fails anywhere. So then otherwise what we can do is just return redirect. And what we want to do is return to the request.redirect URI. So we're going to redirect to this URI, but we also need to add a few things. So we're going to add some new query string params. So we'll take this, we'll do some string interpolation here. And we want to add state, and that's going to be request.state. We send that right back, or actually we should do response.state. Response.state, and code equals response.code. Now, that is perfect. Sweet. And then they're going to send another HTTP post request to the actual API with the authorization code to actually authenticate the user. And we can do that from the API call because that is not going to be through a view. That'll be an HTTP GET request, I think. Let's just make sure we got everything right. So this is the stuff that's sent up the second time around, where we'll get the grant type, we'll get the code, we'll get the redirect URI, client ID, and this doesn't have the Pixie stuff. I don't even want that anymore. Where's our Pixie stuff? Pixie, where'd you go? Please. Generating auth codes. I know how to do that. This one? Code verifier. That's going to get sent up the second time. So we need to handle this stuff from them in the second one in the API call. We'll include the following, and this should be over HTTP GET, where we'll take all of these in the query string params again, and then we redirect one more time, which does actually need to be in the browser, so it isn't going to be an API method, it'll be a different one. Code challenge and code challenge method are associated with the authorization code. The server should already know which method. Oh wait, hold on. Okay, yeah. If the method is plain, then the authorization server needs to only check. Oh, we might have missed something here. If the method is plain, then we just check that they're equals, which is what we're doing right now. If it's S256, then the authorization server should take the code verifier, transform it using the same method the client used initially. This means calculating the hash of the verifier and the base 64 URL encoding. Then compare it to the stored code challenge. Oh, so they're going to send up the original no matter what. Interesting. I thought we were missing something there. So that needs to be down here. which means that we can't, it's down here, we can't just do this. We don't want to find it by challenge. We just want to find it by ID. So let's say to do validate challenge and verified code with S256 hash or plain. So they don't actually send the challenge or the challenged method up again. They just send the verifier. That's interesting. Okay. So that means that here we need to store the method, which we are doing, so that's good. We've got the method. It means that we can't find by code and challenge. We just want to find by code and client ID. Silly me. Get rid of challenge. No more challenge, which means down here, no more challenge. This is by client ID now, which means we get rid of this garbo too. Right. So now we need to actually do the validation. So let's say if auth code dot oops, I was like, why isn't it giving me IntelliSense? Client ID, no more of that. If auth code dot method is plain and auth code dot challenge code does not equal the request dot challenge, then we want to throw an exception. Throw new exception, invalid challenge. Now we don't have to do that. So invalid code or client. Okay. Then we want to say if auth code dot challenge method equals S256, then we need to do some stuff. Then we want to hash and URL encode and base64 URL encode the request.challenge, compare new hash with stored challenge code, and throw if not the same. That's the gist of it. So let's do this. C# SHA 256 hash. There's a built-in class for this. We literally just need to call it. Hash, create, compute hash. I don't want the byte array. Convert byte to string. Is that what it is? There isn't an easier way to do this. Oh, can't do Unicode. It needs to be UTF-8. That's why this person had an issue. It's 2 years ago. SHA managed. Weird. Alright, we're going to go back to the other one. Our handy dandy C# corner method. This bad boy. We've got all our little private little helper token generators and hashers all up in here. I don't need it to be static. I use var. We'll say original string. And original string. And then we need to base64 URL encode it, which is just super weird. Okay, so we'll say var hashed value equals compute 64 or 256. I'm going to say request.challenge. Var encoded equals, there's a, what is it? HTTP utility dot URL encode. That's what we want. And we want hashed value. If encoded does not equal the auth code dot challenge code, throw new exception. Invalid challenge. I think we might need to double check this. I don't know if I need to do some extra stuff other than call URL encode. This I think does the base 64 URL encode. Base 64 does it? Base. That's dumb. I don't know if we're gonna have this base 64 URL encoder. I mean, maybe this will just work. Let's see. I don't know if this is technically gonna do it properly. That's why. Oh, cool. We do have it. There we go. Boom. Now I think this should be fine. Right. So let's reread that stupid code verifier stuff. In addition to validating the standard parameters, the authorization server will also validate the code verifier in the request. If the method is plain, just checks that they're equal. If the method is S256, then the authorization server should take the provided code verifier and transform it using the same method. This means calculating the hash of the verifier and base 64 URL encoding it, then comparing it. Okay. We need to handle like the actual like invalid grant errors, like the actual error types, which we're not right now. I don't even want to do that with the stupid exceptions. I want to do it with the result pattern and handle it from there. It's not adding any responses clients can end. Okay. All right, so I think we're good here then. Let's say I want to add the extra comment just to make sure it's all blocked out. Validate challenge code. We're going to require Pixie if you're going to use us. I wonder how that's going to work in account linking. Do Alexa and Google actually do the Pixie stuff? Alexa, account linking, Pixie. Must support OAuth 2. I know. Does it actually do it? Like, does it do the check, though? It does handle refresh tokens, which is nice. Wait, what? Authorization server should not immediately invalidate. That's kind of sus. I actually really like invalidating refresh tokens when you get a new one. Okay, I want to see the rest of this though. Mobile-friendly login page. Keep track of state. I wonder if they're not going to actually do the check. I wonder if they're not going to actually support Pixie. It doesn't look like it. It doesn't look like they're going to. Let's see. I want to see Amazon spec. Also, let me know if this is too small to read. I don't see anything in here but actually implementing any of the Pixie stuff. I don't like that. We literally just did all of this hard work to do all this extra validation, and if they're not even going to send it. Oh my goodness. That's pretty lame. I'm not going to lie. Does that mean people that force you to use it, like you just can't log in with those accounts? Like if you were to log in with like a Stripe account that requires it, I know they require it because I've used it before. You couldn't actually use Alexa account linking for that? What's up with that, Alexa? What are you doing? Man. Yeah, it doesn't look like it. Well, here's their interesting diagram. It looks way lamer than mine. There's no Pirate Dan in this one. Okay, so maybe we cross that bridge when we get there. Like, we could just do something where if they don't send the code challenge, then we just like don't do anything with it. Maybe. Why don't we just do this? We don't validate that they send it. We could make it optional, or we can make it required for certain clients. We could say if you're the Amazon Auth client, fine, don't have to do it, or the Google one. I don't know what their deal is, but like, if it's clients that we own the actual auth code for, then maybe we can enforce it. That might be the way we do it. Make it client by client. That way we have control over it. I mean, we have control over the whole thing. Like, realistically, we don't even need to do the Pixie stuff. But let's cross that when we get there. Let's get to the ability to actually sign in first. So what we're gonna get on the post back is a different request. Actually, it might go back to the same thing, right? No, it'll be a different URL. So we have this HTTP sign, which will be the base get. We got the post. Now what we want to do is have our public async task iaction result, and we'll call this grant code, and we'll make this another HTTP get, and we'll say, why don't we just call this /code? And this needs to take in all of this stuff except for state. We don't really care about state or challenge method. Okay, so we need these, except it's not challenge. Oh wait, that's not even the name of it anyway, is it? It's code challenge or something, right? Or is it just challenge? I'm like lost in these docs. We need code verifier this time, but this one, that's what we send down. What is going on? Authorization request. Just show me this. Code challenge. That's the name of it. And code challenge method, not just challenge method. Let's make sure we get those names right, because otherwise we're going to see some problems. Code challenge. Rename. Code challenge method. In this one we have code verifier. And we actually have string code. I think that's everything we need. Alright, let's do this. Var response equals await. Auth service. And we have request authentication. No, that's the other one. What is our other method? Authenticate user, authenticate authorization code. That's what we want. New one of these. Challenge is our code verifier. Client ID is client ID. Code is code. Grant type is grant type. And oh yeah, that's everything. We did it. We got it the first time around. All right. So now when we get this, we can redirect them. Redirect, return, redirect to redirect URI. So say redirect URI. And we pass some stuff in. So now we've got access token equals the response.access token. And access token expiration is response.access token expiration. And then we've got refresh token. Response.refresh token. And one more. We've got refresh token expiration, and of course that is our refresh token expiration. Beautiful. I mean, I think we've got just about everything set up other than the UI, which for now we can probably just kind of fake and test like kind of manually, right? So if we were to test this manually, we would send a GET request to this. In theory, that should return a view. Why don't we just do this? We'll say temp. Let's do this. Yeah. We'll comment that out. Get rid of the stupid temp stuff I just typed. For now, I'm going to say temp return OK. This is just for manually testing the logic stuff using Swagger. So what I want to do is send up this stuff in Swagger, and we'll just send it up. And instead of returning the view that will then actually do the login and then the post back to this, we'll just try to send this, make sure we get OK to validate this stuff works. Actually, why don't we just do this? Return is valid. Oops. Then we'll test the post with an actual username and password. And then from there, yeah. Okay, hold on. I'm going to do some stuff here just temporarily. Instead of returning redirects, we're going to return OK responses with the URLs. Right? So same thing here. I'm going to say temp. Okay, I like this. I mean, I kind of like it, I guess. Ideally, we'd set up the UI, but we only got 45 minutes left, and it's going to be a bit. I want to just validate this stuff, and then we can set up the UI on Sunday. Okay. So now, instead of actually doing actual UI login, like transfer stuff, we're just going to use Swagger. We're going to test this method out. We're going to test this one, then actually sending username and password. And then we'll test this out. Before we do the client side, I'm just going to send plain up. I don't want to test the SHA 256, although we probably could. Maybe we can. There's probably some URL thing we can, but that's fine. All right, whatever. I just want to make sure all our business logic is right, and I don't feel like having you guys watch me build a unit test framework because I just don't think that'll be entertaining right now. Once we have stuff set up, we'll add all the regression-based stuff, and we'll be good. Okay, we got our new sign-in controller. So now we can try this out. Now, we do have a client. Let's get that pulled up. I think PG admin's up. All right, we still got this up. Let's open up our local. Oh, goodness. Nailed it. We've got Suave Keys, and we've got Auth client. So let's pull this up because we're going to need to actually add some redirect URLs and stuff. So Auth Code redirect host. We're going to call this just localhost for now, but we can always change these later. All right, save that, save that, save that. And let's put some breakpoints in here. We can actually step through it all now. So we'll put breakpoints on each of these methods, and we'll step in and all the way through, and we'll make sure everything's working right. So now that we've got this, we've got our client ID and secret. We don't even need the secret anymore, which is bomb. We can literally just use a Swagger testing. We've got a user, but honestly, I don't even remember the password that I gave it. We could always go back and watch the Twitch video to see, but I might also just make a new user. Let's do this. Let's see what the email is. Come on. All rows. Okay, it's user@example.com. So we'll just make a new user. So back in Swagger, I'm actually going to copy this to a new tab because if we stop debugging, it's going to close it, I think, and I don't want to do that. So let's create a user. I'm going to use my personal email address, alexander.dunn@outlook.com. We don't have any password requirements right now, so I'm just going to say test123. It's only on my local anyway. No one's going to be able to hack me. Test123. So now we've got my personal email, test123. So to sign in, we can validate all sorts of stuff, and let's make sure we do. So first things first, we need to get all of it right. Authorization code, client ID, we're going to take from here. Redirect URL, we'll say HTTP localhost. Let's see if we have 44326 /authme code challenge. We're going to send up ABC123. State, we're going to send up CBA321. And the challenge method will do plain for now. All right. Let's make sure we got everything right. Auth code, client ID, redirect URL. I mean, all that stuff will come in. So we've got our model. Let's step through this. Do we find the auth client? We do. Is the origin valid? That just kind of blew up. What did we do here? We didn't map origin, so something crashed. Request.headers keys. We don't have origin because it's coming from the same server. So this is going to throw just when we try to access it. What is this if I do it in the immediate window? Nothing. We get nothing there. That's why. There is no origin. So we can't call starts with it because it's going to be null. How do we get the origin? Oh, host. That's why. See, this is why I wanted to open it in another tab, because now we literally need to call it again. Alright, we're back up. Come over here. Sign me in. Alright, now let's check request. Now we should have our origin. There we go. That's what we wanted. Ooh, it doesn't have the... Okay. This is gonna fail. Oh, you know what? You know what's wrong? We literally just talked about this. We didn't make that last migration to add the origin, so it's gonna fail when trying to access it. 3. Auth code new properties number 3. Eventually we'll get all the properties right. Did it do it? Did it not? Hello? Is it even running? I don't know if this is doing anything. We got auth code properties and auth code new properties too. We probably should just squash these into one. Let's try that again. There we go. Now update the database. So now we'll have the origin one. We do need to add that. Wait. No, that was... We already have that? What's in here? Oh, we added user ID. Yeah. Oh, I never saved. Oh no. HTTP localhost. Save. Save. Just say localhost for there. Okay. Now it's saved. Now if I re-execute, we're good. Alright. We should be able to run it now. This was adding the user ID to the authorization codes. I totally forgot about that. Get away from me. Let's come back over here. Let's try to sign in again. Or try to request an auth code. Or even just make sure that we're literally allowed to render it. Right. Request.origin. And we've got... Now we've got these. Okay. So now we're good. Alright. Request.redirect URI. HTTP... Oh, it doesn't have the // Did I mess something up there? Oh, I didn't. This is good. We're valid. We just validated it. Sweet. We got an error because it's an invalid redirect URI. Kind of right. When we switch to the result pattern, that'll be a lot nicer. All right, now we can do this. Let's just run it. I think it'll work now. Yes, valid is true. Okay. So now we want to do the same thing on this one, the actual post. And now we should see the URI, except now we need username and password. So this will be alexander.dunn@outlook.com. The password was test123. Client ID is that. The redirect URL I want is this. The challenge I want is, what do we do here? ABC123. The grant type is authorization code again. It's basically the same values. Like realistically, this post will never happen from the API or anything. Like this is exclusively going to call from our side. There's your state. Origin is local host. And the challenge method is plain for now. Oh, yeah, we got the challenge. ABC123 states. Okay, yeah, we're good. Let's see. Let's step through this again. Okay, grant auth code. Get the user. Hey, we got a user. Is password match? Hey, they signed in properly. Is valid? I sure hope so. We just did it. All right, now we get the auth code and we generate it. Let's make sure we've got everything in there. We do. We've got our challenge method and our challenge code. So then we send back down the code in the state. And now instead of redirecting to this URL, we're just going to return it. So now our response in the Swagger UI, this is realistically where we would redirect to. So we've got our lovely code. This needs to change. These are some invalid characters. We can't have asterisks. We can't have question marks. These are not cool. The state looks good though. We send it back down. So here's what we need to do. Good thing that we're testing this now. If we go to our user auth service, when we do this generation, because we copy and pasted it from the internet, we need to change some of these values out. So we can go back here and look at the valid parameters. Where was it? Is it in the Okta one? No. Where are you? Here we go. Letters, numbers, capital letters, these ones. Those are the only ones. So I'm literally just going to copy these and replace these. So we've got uppercase letters, A through Z, lowercase letters, A through Z, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and those beautiful characters. So now we can generate a valid auth code. Another tab. Over here. Over here. Run it. Spin it. We got state, we got code. Look at all those beautiful characters. So now let's hold on to this. If we go look at our database, we should see in Suave Keys Schemes Public, we will have a table for authorization codes. So if we view this, we'll see the two. One of them we don't care about anymore. And we've got our good one, right? So this is the bad one. Bad code. This is the good one below here. So we've got the challenge method and the challenge code stored. So now we can actually send some of this stuff back up the second time. So now what we want to do is say grant type. Again, authorization code. I'm going to just paste the code there before I forget. We got ABC 123. Redirect URI. Localhost 44326 / redirect again. Client ID we'll just take from up here. Oh, I'm gonna sneeze. Excuse me. Alright, client ID, grant type should be authorization code, right? Or is it's something different on the way back up? No, yeah, it's authorization code. Okay. Yes, of course. Yeah. I think technically we're not supposed to validate the authorization code the first time. The grant type, rather. Authorization code. So this should work. Bam. Let's step through it, though. We got 5 minutes before it expires. Oh, we didn't check expiration. That's another thing we got to do. Okay. Let's start checking it. Let's make sure our model looks good. Everything's there. Find the auth code. We found the auth code. If the challenge method is plain, we're good. If the challenge method is that, we're not good. Okay. Redirect starts. Grant type is authorization code. I'm going to put a to-do validate expiration. Now we literally just sign in. We generated an access token. Look at that. View. Set up all this goodness. and we should get our actual response. Or did we break something? Did we break something on save here? Uh-oh. Uh-oh, what did we do? I never got here. I think we might have hit an infinite loop somewhere or something. Is it, I wonder if it's because we're trying to remove this even though we're trying to access some stuff off of it. But that doesn't sound right. There should just be a value. It froze up on save changes. But why? We must have hit an exception somewhere. Here, let's do this. Run it all the way. Oh, there we go. Invalid code or client. Oh, we already deleted it. It should be gone. Yeah, it's gone. We never got our response back, though. Oh, there we go. At least we know that if we use an old token, then it's bad. I'm going to get rid of this breakpoint. That way we can just generate new codes. Right, so this code is what I need. I can just send in this place. Okay. That worked. Why is it still spinning? Oh no, we're returning redirect. We don't know how to redirect from here. I want to return OK. Okay. I think this will be it. I think this is it. We're just about there. Then we'll validate the SHA-256. This is going to be expired, so it's going to fail. That's fine. We'll generate a new one. This one got a lot of periods in it. Yeah, look at that. All right, now the true test. If we take this access token, I think that's all of it, and we go to authentication, right? If we try to hit off this test endpoint, we get a 401. If I throw this in my bearer header, or my authorization header with bearer, we get the user ID. Boom! Authorization code grant flow with Pixie implemented from scratch with a whole bunch of holes in it. Because we were not validating expiration dates and we're not actually returning the proper error redirect stuff. But damn, we got it. Like, we were able to sign in. That's pretty sick. That wasn't too bad. I mean, like, pretty little code. Let's do this. Let's add the expiration. I'm going to do it before we even do all this stuff with the auth code matching. We'll say if auth code dot expiration is less than datetime.utc now, then we'll throw a new exception. We'll say invalid expired code. Hell yeah. Yo, that was pretty easy. We got to validate this stuff, though. We got to validate the hash. So let's do that. So using the same exact setup, not in Edge, though. Okay, so we can get rid of this. Here, instead of saying plain, we're going to say S256. Oh, you know what? No, that's bad. I shouldn't have done that. I need to actually truly generate this challenge in SHA-256. 256 hash online. There we go. Base 64 URL encode online. This. Boom. That's what we want. Alright. So if I send this up and say it's S256, right? We get this code. Now, if I try to pass up this code, if we pass this, so let's validate a couple things. If we pass up the raw, this should fail. We get rid of the breakpoint. Invalid challenge. If I send up ABC 1, 2, 3, 4, that should fail as well. Same thing. Invalid challenge. If I send up ABC 1, 2, 3, this should succeed. Invalid challenge. Shit. Alright, maybe we should step through it. Run. Challenge method is S256. Hash value. Encoded. Something is off. Is it because there's like a line break here? Interesting. 6CA13. It's the same, but this is lowercase. Uh-oh. Why? Is it the online one that uppercased it? Let's try a different one. Okay, okay, that's fine. Yeah, I mean, it's going to be totally different. I don't know, we just used a bad online generator, that's why. Alright, that's fine. What we're going to do is generate a new one. We're going to send this challenge up instead. That seems like the proper one. Take this code and use it instead. If I send 5, that should fail. Invalid challenge. Invalid challenge. If I send 1, 2, 3. Why? Come on. Is it the equals equals? Is this just throwing it on at the end? Let's look. Let's look. Gotta step through it. I'm gonna send it up again. We're so close. Yo, what? Ah, shoot. I hit the wrong one. This should still be fine. Auth Code challenge. M starts with NM, ends with MA equals equals. ABC 1, 2, 3. Encoded. NM, MA. Oh, there's no equals equals. Who's wrong here though? Is it me or the online generator? I mean, who's to say? This one feels like it's not actually URL encoding. This just feels like it's a base 64 encoder. Yeah, see, this one didn't give me the equals equals. Get out of here. Miss me with that. Cool, so the equals equals was dumb. What is equals equals is space, right? Oh, not the shot. I don't want that. Alright. One more time. Except no stupid equals equals. Take this code. That's the one we're sending. That's gonna work. Give me that. These are gonna equal. Boom. Get them out of here. Freaking Pixie supported Auth Code grant flow. Easy. Alright. Let's do this. Let's commit it. We're going to say whip Auth Code grant flow with our goal. with our user accounts. Needs proper redirecting and actual UI for signing in. How about that? All right, I think this is a good place to stop. Sunday, right? Today's Wednesday. Sunday, 12:30 p.m. Eastern. We're gonna be back here working on the same project. We're gonna build the Auth UI to let us actually sign in, and then we're gonna actually get signed in on Alexa and start sending requests. I really think this is the last of the boring stuff, because after this it's all Flash UI stuff. We're gonna be building more Alexa skill stuff, more voice interactions, more mobile apps and desktop apps, and once we get the account linking stuff out of the way, like, we're just in such a better spot. So Sunday, let's say goals are to set up all the redirect stuff, get this deployed on Azure. We need to spin up a Postgres instance on Azure, make sure we're not committing our stuff to source control for our actual staging and production environments, and then we're going to get it deployed, get the actual UI set up for signing in on this server, and then start actually generating some stuff for client IDs to be able to sign in on Alexa, Google Assistant, and the apps. And then after that, we'll start setting up the app. So let's just make a goal of next Sunday to actually make authenticated requests from Alexa through Voicify down to our webhook we have, and just pull access tokens out and see what we can do with that. And I think that's gonna be it. Should be easy peasy. So thanks everyone for joining. Thanks for everyone that participated. Thank you Sushi Codes for the follow today. And I'll see you all Sunday afternoon on the East Coast. So peace out.